Okay, now we have a unit circle that is completely filled out with all of the different coordinates that we've just labeled, all on one. So let's recall here that in a unit circle we have an x-coordinate, a y-coordinate, a radius of 1, and here's my angle, so that cosine of theta is just equal to x, because it's x over 1, which is x. Sine of theta is equal to y over 1, so it's y. And tangent of theta is equal to y divided by x. So when I'm talking about x and y here, I'm literally talking about the coordinates on the points, because these are my x and y coordinates. So these are x and y coordinates here. I kind of meant to make this drawing a little, I don't know if I can lower it down a little bit so I can add one little point here, because this is the xy point on the circle. All right, so I can use the coordinates of the point to tell me what cosine and sine are. Now let me show you why we use the square root of 2 over 2 instead of 1 over square root of 2. It turns out that all of our fractional values for our coordinates on the unit circle can all be written as a fraction of 2, so that it keeps the pattern 1 over 2, square root of 2 over 2, square root of 3 over 2. Interestingly enough, if we were to look at, let's say just look at the y coordinates here, as we go from 0 to 90, notice we start out with 0, then we go to 1/2, then we have square root of 2 over 2, we have square root of 3 over 2, and then we go to 1. Well, think about this. 1/2 could be written as square root of 1 over 2. 0 could be written as square root of 0 over 2. And 1 is equal to square root of 4 over 2. So I actually have this really interesting pattern of everything is can be written as a fraction of square root of 2 over 2. 0, 1, 2, 3, 4, square root over 2 give me these key points for the special angles as I go around the unit circle. The other thing I want you to notice is this is obviously equal to 0, 1/2 is equal to 0.5, square root of 2 over 2 is 0.7, square root of 3 over 2 is 0.87, and then of course we have this is 1. Okay, so 0. So remember when we drew a right triangle on Desmos and we moved the point and we noticed what was happening to the adjacent or the opposite side? The opposite side on the x-axis here is 0. There's no opposite side. As we move this point around, we see our opposite side growing and getting bigger and bigger. So the opposite side is now has a distance of 0.5, now it has a distance of 0.7, now it has a distance of 0.87. So you can see the sine value growing. When we get to the top here, there is no adjacent side, and the opposite side is right on top of the hypotenuse, and it equals 1. Then imagine what happens as we move into quadrant 2. Now we're down to 0.87, so this is 0.87 again. Now we're down to 0.7, 0.5, and then we're down to 0. So if I'm just looking at my sine values, notice my sine values increase up to 1, and then they decrease, so 1 is the maximum value that I can get for sine. Now if I go down into quadrant 3, notice what's happening to my sine values now. They were at 0, and now it's negative 0.5, negative 0.7, negative 0.87, down to negative 1. So my very lowest value for sine is negative 1, and then it goes back up again, negative 0.87, negative 0.7, negative 0.5, up until I get to 0 again. So this gives me the pattern of how sine changes as we move around the unit circle, or move around any circle for that matter. So what is the big idea here? We're going to create a trig function. We've talked about trig values using SOHCAHTOA. Now we're going to create a trig function. A trig function has an angle for an input and a trig value for an output. And when I say trig value, I'm talking about the trig ratio, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Those are the trig values. Those are the numbers we get when we do those ratios. So let's think about, so let's recall here just kind of the way we do functions. Recall that f of 3 equals 5 means 3, 5 is a point on the graph of f of x. So how does that relate to our sine function? If we say something like sine of 150 degrees equals, and let's go up here, sine of 150, it's the y coordinate of the y coordinate is a sine value, so sine of 150 equals 1/2. That means the point 150 degrees comma 0.5 or 1/2 is on the sine graph. We can do the same thing with a cosine graph and we'll also do a tangent graph, but we're going to do a sine graph first. So we're going to look at all the y coordinates of this unit circle to draw our sine graph.